Okay, so let's start to this problem of the day, that is the knight's duel problem. Let's read the problem statement. You are given an integer n. There is an n by n chessboard with a knight starting at the top left corner. Your task is to determine a valid knight's duel, where the knight visits every square exactly once, following the standard movement rules of a chess knight. Two steps in one direction and one step perpendicular. For example, if a knight is placed at cell 2, in one move, it can move to any of the following cells. So you know the chess game, right? So in the chess, knight is like the Ghoda in Hindi, right? So that particular, yeah, that particular has movement, which is two steps in one direction and then one step in the perpendicular direction, right? So you have to return the order in which each cell is visited. If a solution exists, return the sequence of numbers starting from zero, representing the order of visited squares. If no solution is possible, return an empty. So basically, you have n by n chessboard. Like in this case, n equals to 5. So it is a 5 by 5 chessboard. And you have to find a path in which the knight will be visiting every cell exactly once. And it will cover every cell of that chessboard. Right. So it starts from the 0, 0. And there, this is mentioned that it is 0. It means it can reach to 0, 0 in 0 steps. Right. Okay. After that, it will make its first move. It will reach us to 2, 1, right? So basically, it has a value 1. It means it can reach this particular cell in one move, right? And after that, it will move to this particular cell, that is 0, 2. So it is mentioned that its value is 2. It means it can reach to this select after 2 steps, right? So after that, it will reach to this cell, that is 1, 0, and then it will reach to this 4, 1, 3, 1, sorry. So basically, in this way, it will keep moving in the chessboard, and it will reach every cell exactly once, and it will cover every cell of the chessboard. So it's like 24 at this point. This will be the last move of the night, right? So it's a simple problem. N is less than equal to 6. It means we can uh, somewhere use maybe backtracking or recursion. So let's think about this problem. So we have a starting point 0, 0, but we don't have any final location, right? So it's not something like DFS and AFS. It's kind of DFS, of course, but with no target. And every cell would have 8 possible moments, right? Like this problem experiment itself has given the moments. So means at every cell we can make eight moves, right? So we will first try to decode what will be the moments I can take if I'm standing at a particular cell. So I have made a two array which will be deciding a direction of the row and column. So after analyzing all the 8 moves, I created these two arrays. Means I can go to top left direction, and it can be of two different ways. That is one in the vertical and two in the horizontal. Then two in the vertical, one in the horizontal. So each four directions would have two choices, two possible moments, right? So in total, there will be 8 moments. Okay. So now we are clear with the number of moments and what will be the moments, right? Now, if I'm moving to a adjacent cell in after making one moment, so there will also a case that okay, if I make a one moment, now I want to make one more moment to visit another adjacent cell, and in this way, I will keep moving from each of the cells. And if I visited all the cells of the chessboard, it means I have founded a particular path, right? So I will return that particular path. So basically, I have to use another board which will be storing the moment number, means to basically output the output basically answer. So yeah, so now we have a clear vision. Now I have to use a board, that is visited board. If I made a movement to that particular cell, that means I'm coming from the previous cell. So this will be the moment number of +1. That would be that was the moment number of the previous cell I was coming from. So basically, I have to use backtracking because whenever I reaches to a cell and I didn't found any possible moment from that cell, and chessboard also not filled completely, then it means I cannot move. Then I have to return back to the previous state to basically check for other options, right? Other moments. So in this way, I have to keep coming back, keep coming back whenever I got failed to find the perfect solution. So I started with the base case. The base case is very clear. I have to make sure that I have filled the board completely. So it will be the case when I am standing at a particular cell and that cell is already being visited with the moment number equals to n square minus 1, right? Because for 5 by 5, there will be 25 minus 1, that is 24. That will be the final moment number, right? So this will be the base case for this recursion. So okay, now I have 8 moments from this current cell, of course. So I founded the adjacent cells and then I'm checking for the validity, right? Either that particular cell is being in the chessboard or not. So I just a simple check that okay, this particular cell should be within the board, not be overflowing out of the board. So after checking the validity and also I'm checking the either this particular cell has been visited or not because it is mentioned in the problem that I have to visit every cell only once. So I'm checking for the visited array also. Now I'm after checking validity, if this particular cell is has not been visited and is within the chessboard, then it means I can make a move, right? So I will make a move and I will add into the visited chessboard that okay, I have visited this particular cell with the moment number plus one, then the then from I am coming, right? Now, if after after making certain number of calls or basically moments, if I get visited to the last cell of the moment to basically fill the chessboard completely. So if that particular solution has been found, then I just have to return back because I have completely found the solution and I have to remove that recursion stack, right? So for that, I'm making return statement to itself. And if I didn't get any moment, or basically uh, fail to found any moment of in the next moment or next cell, then it means I have to make backtrack to the previous state that okay, I didn't found any moment further to make the possible solution. So I have written back. So I just uh, making backtracking and I'm again making that particular cell unvisited. Right. Okay. So if this will be the case when if I did not get any move from current cell, then it means I cannot find any solution with yeah, of course, with that moment. So return that, right? So if we didn't get any s- perfect move to fill the chessboard completely, then just grab return that. And after every possible calls and after uh, removing all the recursion stack, if I found the solution, then I will return the visited array because it would have the step number that I have to return. Okay, so this is the possible solution I found with myself, and I hope this is very clear to you also. It is covering everything, every each case, and also I have explained each of the line why I did this, and let's discuss the time complexity also. So as you see, there are eight movements, right? Yeah, 8 movements at every cell. Means every cell can have, in the worst case, 8 possible moves, right? So it means the time complexity would be 8 to the power n square, right? So this would be the time complexity of the solution. And if I talk about the space I'm using, that would be equals to, of course, there are n square cells. Then in the worst case, the recursion stack would be filled with n square number of nodes or cell. So yeah, perfect. So there will be n square space complexity and e to the power n square time complexity in the worst case. But yeah, in the average case, it would be a lot lesser than this, right? So hope this is very clear to you. And yeah, make sure you like and subscribe this channel. I'm saying this for the first time because I want your support to uh, make myself consistently uploading the videos of the solutions, right? Thanks for watching.